Hello YouTube, my name is SH and I'll be talking about the Vapour Absorption Refrigeration test kit that I've built for my final year degree project, and it goes as follows. What I've done is I've taken two compressor shells. Those were empty shells, only the stainless steel body. Inside everything was removed and thrown out. The generator was the first shell and the absorber was the second shell. What I have done is I have drilled 1, 2, 3 holes in the generator, 1, 2, 3, 4, 5 holes in the absorber, and I have taken the bottom hole of the generator, connected to the top end of the absorber, and connected through a capillary tube which was a 0.3 diameter and 6 meter long, turn into 10 turns. And in similar fashion, what I was the condenser and the evaporator were connected using the same 0.3 diameter capillary tube with 6 meter length and 10 turns. These pressure gauges were introduced in between the pressure gauges between the condenser and the capillary tube, as well as the capillary tube and the evaporator. These were dual way control valves, and this evaporator is nothing but a stainless steel box or a container in which copper tubes are wound across in 6 turns and then connected back to the absorber. Here what happens is, in the absorber is I've connected a pipe 3 by 8 inch diameter, connected to a 12-volt DC pump, set a mass flow rate of about 700 milliliters of water per minute, and that is around zero point 0.1 kgs and kg per second. And I've connected to a valve and then again back to the generator. This valve was to set the mass flow rate, 700 ml per minute. This pump was worked on with a 12-volt DC battery. Generator was heated using a 1000-watt heater, which was connected to a thermostat, and a temperature of 75 degrees was maintained. So what happens over here is, when we put lithium bromide solution through the inlet into the absorber, it stores into it. So I was storing about 4.5 liters of lithium bromide in this. It was in the concentration of 55% lithium bromide and 45% water. So what happens is, because of the pump, lithium bromide solution will be pumped up into the generator. In the generator, because of the presence of an heater, the water and lithium bromide will get separated. Lithium bromide will come back into the absorber, whereas the water vapor will start rising into the condenser. This condenser was 10-ton condenser, which is available in the market, and it goes into the pressure gauge where the pressure of the water vapor is noted down. Then this passes through an capillary tube where the pressure reduces as well as the temperature, and it goes into the another set of pressure gauge, which measures the pressure of the liquid and vapor, and then it goes into the evaporator. Here what happens, because of the expansion in the evaporator, the temperature of the um, water filled inside the evaporator is reduced because of the latent heat of evaporation, and this vapor is converted back into liquid and will join to the absorber. So the lithium bromide strong solution and the water mixes again to form a weak solution here, and the cycle keeps on repeating. This is how I finished my final year engineering project, and it successfully got a COP in the range of zero point 0.6 to 0.66. And this is my project report, which was done in the end of the as a conclusion for my project. The specifications for all my components are given below. This was a 2D sketch which I had built. This was the experimental front view and the rear view. This was my generator. These are the specifications are given below. The evaporator, condenser, absorber, the connectors, pumps, pressure gauges, thermometers. Thermometers were fit whole across the system. You will come to know as you proceed through the report. Valves, battery charger. This was a thermostat used, thermostat, and I set it up to 120 knob. So one thermometer or thermocouple was attached to the inlet of the generator, one to the outlet of the generator, one inside the generator, or across the generator to measure the temperature of the liquid inside the generator. One was at the condenser's outlet, then one at the inlet of the evaporator, outlet of evaporator, and inside the evaporator, that is inside the water what we are cooling. An actual COP, relative and theoretical, was calculated using these formulas below. These formulas were obtained from an IIT, Indian Institute of Technological textbook, and considered to be correct. So I conducted three tests on three separate different weeks, and I obtained COPs and temperature readings, and I plotted them with respect to time. This was time versus temperature. This was the COP versus time. I was conducting a repeatability test to whether identify whether my system is working in the given range. This was on 13th of May. That was on the 4th of May. Time versus COP. This is last on the 22nd of May 2017. This was time versus temperature, and then I compared all the three actual COPs of three trials, similarly theoretical and similarly relative. And this was my cost analysis, about 33,126 rupees, and my conclusion and scope of each work, and these were the calculations remaining. I wish you all the best of luck if you are building this test rig, because it is a wonderful project, and it has future scope with it. I made this video because I had problems and difficulty in making the test rig. I didn't want people like me, not struggling like me, to make this test rig. Thank you. Cheers. Bye.